Now it's ready. Question 5 was the long division question. Find the quotient and remainder when that is divided by that. It's not a particularly difficult long division either, is it? Because there's no missing term, and that's what we find difficult in long division. I'll do it with the grid method, but you can do it with the bus stop method if you wanted to. So the grid method would say, if we divide it by that, here's our grid. We've got 2x squared plus 4x and plus 1 that we're dividing by. The first term is a 6x to the 4. So what do we multiply 2x to the 4 to get 6x to the 4? That should be a squared, sorry. I don't know why that happened. What do we multiply 2x squared by to get 6x to the 4? The answer is 3x squared. We write 3x squared there. Yeah, I'm doing it wrong. Right, we'll start again. We'll pretend that none of that happened. So that's a 6x to the 4 that we need. Thanks, Jack. So we get a 3x squared there. Is that better?
Yeah, no, it's fine.
Okay, thanks. It's good that you're here. Now we complete the rest of that column. So 3x squared times 4x gives us 12x cubed. 3x squared times 1 gives us 3x squared. We are supposed to have 12x cubed. Haha, we've got 12x cubed. That means that here we must have a 0x cubed to complete the total of x cubes. That's interesting. That means that 2x squared times 0 is what we need up there. And we're going to fill in the rest of this column with zeros. We would have 0x squared from multiplying those two, and 0 times 1 gives us 0x's down at the bottom. Now we've got to check how many x squareds we've got. We've got 3 of them. 3 plus 0 is still 3. We're supposed to have minus 3, so we're going to have to take away 6x squared up there. What do we multiply 2x squared by to get minus 6x squared? The answer is minus 3. Checking that Jack's agreeing with this. King of this. 3 times 4x, that gives me minus 12x. Minus 3 times 1 is minus 3. We're supposed to have minus 11x. At the moment we've got minus 12, so we need another plus x over there to balance that up. We're supposed to have minus 2. We've currently got minus 3, so we need a plus 1 there as well. And so now we need to say that the quotient is 3x squared minus 3, and the remainder is what we have hanging over here in green, x plus 1 is the remainder. Good work. We've got a second part to do. So that was 3 marks for that. They were looking, the marks were allocated for, I don't know where it is, oh yeah, for 3x squared in the quotient and some kind of visible site that you use the minus 6x squared somewhere as part of a term in your division, so that kind of has to appear somewhere in there. And then the other marks, we're forgetting the other bits right. Okay, hence show that this gives you an answer in that form when you have to find A, B and C. So hence integrate the integral from 0 to 3 of 6x to the 4 plus 12x cubed minus 3x squared minus 11x minus 2 over 2x squared plus 4x plus 1. There's no tricks here, are there? Because that exactly mirrors what you've done in the first part of the question. So that's all right. This means that we are integrating between 0 and 3. So we've got a quotient of 3x squared minus 3 and a remainder of x plus 1 over 2x squared plus 4x plus 1 dx. That's what we've ended up with at that point. Okay. So now we've got to think about how we would go about integrating those things. The first part of it is a simple expression to integrate. That's all right, isn't it? That is, add 1 to the power and divide by the new power. 3x squared goes to x cubed, and minus 3 goes to minus 3x, between 0 and 3. Now the second part of it, if we think about how we do that, we spot, hopefully we spot, well there's two things going on here. We know that we're being led towards a natural log answer. How do we get natural logs in an answer? We do that by what we are terming as Craig's rule, the rule where we look for the top being the derivative of the bottom. The top is almost the derivative of the bottom. If you differentiate the bottom line, you get 4x plus 4. And we've got x plus 1. So, if we slightly alter this, if we say this is 4x plus 4 over 2x squared plus 4x plus 1, if it's that integral, then that's perfectly set up for us to treat it as Craig's rule and get our answer. Of course, if we do that, we've multiplied the top by 4, which changes the value of what we've got. So we'll also divide by 4 to keep it worth the same amount. So we have, we could work out this limit at this point, couldn't we? Because that seems like a sensible thing to do. If we sub in the 3, that gives us 27 minus 9. If we take away the subbing in 0, we would take away 0. And we've got a quarter times the natural log of 2x squared plus 4x plus 1 from that bit, because the top was the derivative of the bottom. So we have 18 at the start of this. I've neglected the limits in there, but that's between 0 and 3. We're now going to sort out the limits, so that is plus a quarter of the natural log of, what do we get if we sub 3 in? Sub 3 in we get 18 plus 12 is 30 plus, is that right? Have I done that right? 31. And then 31 minus a quarter of the natural log. And if we sub 0 into that, we get ln 1. But the natural log of 1 is 0 anyway. So we've ended up with 18 plus a quarter ln 31. And that was the set of values we were after. It wanted, notice that there's a little subtle difference here. It wanted you to show that it was A plus B, L and C. It did say that A, B and C are constants to be found, so maybe you could have written A equals B equals C equals, but you didn't have to. They were happy just to see that as the answer. And that's some maths.